Hello and welcome. This is a talk about GitHub Agentic Workflows, which is quite a topic these days. And I gave a talk at Microsoft Munich, and I want to share this information with you. So my name is Bernhard Merkle. I'm a technology scout at SIG AG, Microsoft MVP also, and I gave this talk at the Technical Summit in Microsoft in January 28th. The topic of the talk is the rise of agentic workflows, AI that understands and decides and codes. And mainly what I want to show you in this video is how GitHub agentic workflows are working and how this will change the way we will develop software in future. So a bit about me. I'm working at a company that's called SIG Sensor Intelligence, and we are producing sensors. For example, you might have been in contact with a sensor or with the result of sensor measurement when you use Google Street View, because on the Google card there are these cameras, and below the cameras there are LiDAR sensors from SIG AG, and Google has put them upside down and removed the labels of the sensor. So this in the red circle is a SIG sensor, which the label was removed, and this gives you the 3D feeling in Google Street View. But today we want to talk about GitHub Agentic Workflow, which is a very new way how we will develop software in future. So let me first position where agentic AI or the agentic workflows are. We have different things in the AI area. We have large language models, which are kind of smart text generator. You ask it something and it writes back an answer. And RAG is a kind of AI that searches through our documents, so things that LLM do not know, but which I can ingest in the answer. Then we have AI agents. So AI agents are essentially helpers that can plan steps using different tools and complete whole tasks for me as programmer. And in the last column you see agentic AI. This is a team of AI workers where each one has a different job, and they work together to finish big projects. And essentially here we are talking about agentic AI. So I've used this Minecraft style a bit. You will soon know why I did this. So LLM, we can say in short, LLM writes, RAG knows, agent acts, and agentic AI manages. So this is a good way, I think, to remember these topics. In this talk, I want to show you a bit of GitHub Agentic Workflows. This was previously a project at GitHub Next called Research Preview. Since 2 days now, it's officially hosted on GitHub. So they've changed the URL, moved repos and all this documentation from GitHub Next to GitHub. And it's called a technical preview now, and I would assume that it soon will be also a real product or become a real product. And what does agentic workflow do? It enables us to write AI automation in a natural language, and that's a key change how we can develop software. So if you look at the DevOps workflow or continuous integration, we now move in these AI times from continuous integration to continuous AI. So what do we do normally in software development? We have a feature, we plan it, we document it, we code it, we run a build for it, we test it, then later we release it, deploy it, operate, monitor the feature, and then the circle starts again from the beginning. Yeah? And these things can also be done with the help of artificial intelligence. So, for example, we could have an autonomous agent that does issue triage, or agent that does plan new features. So, auto-generate a plan for the implementation, or that plan bug fixes, or it does code for you. That's mainly the point with code. You you already maybe aware of when you use some coding tool like GitHub Copilot or something like that. It can also help with code reviews, but Agentic AI can do much more. It can do document generation, accessibility reviews, etc., etc. So with this step, I think we make another evolution from large language models to software engineering agents. So we started essentially in 2021 with GitHub Copilot, which is an AI-powered kind of code completion. And then later on, we had this ChatGPT with conversational AI assistants where we can prompt, yeah, and instruct, so that GitHub Copilot, for example, generates, or any other coding agents generates code for us from our natural language. Then in 2024, we had these agents like Claude Code, where we can then yeah, do complete development projects. And in 2025, we have now model context protocol and skill markdown files and other files where we can then configure also these agent tools. Yeah, one, and we have a kind of unified tooling via the MCP protocol. But one major drawback, I would say, we still had in 2025 is that these agent IDEs are kind of solo development. So this your prompt is not shared. It stays on your machine. It's not really traceable. It's not enterprise ready. You cannot really work together in a team or see what other have done. So if you lift this solo agent IDE to the enterprise level, I think we can speak from continuous AI, and that's the topic of agentic workflow. And one guy which I was in contact also at GitHub Next was Peli, and he is also the author of Make Code and Minecraft language, Minecraft layout for a language there. And so I decided to make my presentation a bit Minecraft stylish. So if you look back how it started, we had this instruction that we write in, for example, GitHub Copilot, and then it starts to implement code. But we got further, and instead of only implementing code, now the agents can triage bugs, they can create a plan, they can implement a bug fix, and later on also check the code quality automatically. Yeah? But we scale this out. So now today we have bots that spawn up new bots, and so a bot can command additional agents which do then subtasks like compiling or deploying or monitoring. I think you get the idea from this picture, yeah? And if we think this on a higher level, then and if we make it enterprise ready, then we speak of continuous AI. That's the thing which I showed you with this DevOps circle. And then essentially all the work from this DevOps circle is done by autonomous agents, and we as human in the loop only merge the pull requests which the agents have created for us. And this is really possible today, for example, with GitHub Agentic workflows. So GitHub Next is running different research projects, and two of them are agentic workflows. The URL is here, so this is a research prototype, and here you see the team that made it. And we also have a project here, continuous AI, which explores usage of LLM and agents to yeah, um, make the software engineering process much more efficient. Yeah. So how does it look like if we write these GitHub actions for continuous integration and continuous development or deployment? We write a kind of YAML workflow as a configuration file, which is stored in the GitHub subfolder in our development project, and we can trigger on certain events, or even we ourselves as user can fire them up. So this is a kind of example here in YAML, where we have, for example, if we have open issues, yeah, we have here a workflow that can summarize um, the issue and respond with a comment. Yeah, and of course you see here the agent has some permission. So, for example, if he adds a comment into these issues, he has to have write permissions on this task, and that is of course kind of danger zone, because agents can do things that we do not always want. Yeah? They can react in a certain way that we don't want to have. This even It is also known at the little Traphasia for AI agents. So AI agents become really risky when they combine three capabilities at once. There's a good blog about this. The URL is there. If you have private data access, if you have untrusted content, and if you have external communication, then you have to be very, very careful, because people can inject, can use prompt inject to do things you didn't want to have, or they can access your private. It's possible that they could access your private data. Yeah, and one example that I also saw one day on Twitter, on X, was some user said to his agent, please delete my log files and debug files from my software project, and the agent cleaned his home directory. Not sure if that's really true, but the story behind it is that some LLM was not created in a real good way, and the LLM had learned from articles of Stack Overflow, for example. Um, yeah, somebody asked these questions: how can I delete my log files and debug files? And some people make joke of it. Just do r-rf in your home directory, and some people also upvoted this article. So this is how the thing was then propagated into the LLM history. So I'm not sure if it's really true, yeah? But these things can happen, and we should therefore make countermeasurements against this. Yeah? So, and one thing is that GitHub Actions is very, very serious about creating only safe software engineering agents. Yeah? So we have things like um, permissions, um, which are read only by default, yeah, so least possible permissions, and we have kind of safe outputs. So if we have add a comment, for example, to an issue, we can have guardrails for write operations. Yeah? And um, this topic, or this idiom is done safe by default for different aspects. Yeah, you see here for containers, for example, we have isolated GitHub action jobs. We have network control, we have minimal permissions, so read only by default. We have secure tool access only via MCP proxy. We have the safe output, and we have also at certain points human in the loops which plan and act, etc. So this is a very important topic, especially if you want to use agents in the enterprise. If you don't have these aspects in your architecture, in my opinion, the approach will fail. And this is a very good example here in GitHub that it's already baked into the architecture. So we are really safe, and we need this safety if you use it in a team or in enterprise. For AI engines that you can use with GitHub Agentic Workflows, we can use multiple AI providers. There's GitHub Copilot as default, but you can also use Claude Code, Codex, or even, I think, in future versions, bring your custom engine and bring your own AI for development. So here's a overview of the documentation, how GitHub Agentic Workflow works. There's also a good quick startup. I will not repeat this here because you can see a very good demo and video there in the quick start guide. What I want to show you is a bit example which I interactively developed together with the agent. So what is the prerequisites? Is a AI account. You have to have some access to Copilot, Anthropics, or Codex. I showed you the flexibility that different AI providers can be used. Of course, you need a GitHub repository and action enabled in your repository. And then you need the GitHub command line tool, which you can install. Yeah? In minimal version is version 2, and then you install extension, we'll see this. And it's available for different operating systems, so Linux, Mac OS, and Windows, and VSL, Windows with VSL is supported. So how does it work? After you have installed GitHub command line, you install this extension here with this command, GitHub Agentic Workflow, and then you initialize the repo so that agentic workflows can be used. And in this example here, I add a workflow daily repo status, which is already implemented and available via a kind of library or collection of workflows on GitHub Next Agentics. I will give you more information about that also. So there's a library where these workflows are described with Markdown files, and then you compile this Markdown file. It ends up in a log YAML file in your directory. So this compiles it, checks also security issues and etc. And then you push this workflow to your GitHub repository on the server, and then you can trigger the action. So that's the idea. And there are of course different workflows here. Yeah, you can compile it, you can run it, you can see the logs, you can see the status if there are problems, you can see the log files, look at the specific run in detail with the audit command, etc., etc. So there are a lot of commands here which I will not go into detail here. Rather, I want to show you how I develop also a workflow myself and how I added here, for example, a new command into the GitHub Agentic workflow tool. So let's go over to my browser, and here I have a small demo example, yeah, where I created a Python project. This Python project has just a small library here where we have a hello world function, and this can be used here. I've created here a small example, how you use the library, how you compile it, how you deploy it, etc., etc. Yeah? And now I want to use GitHub Agentic Workflows to help with my software development project. And what I did is I created here, um, I will show you um, the workflow, how it runs. So I created here, I instructed the agent to create a workflow. Here is this command here, um, to create a workflow that triages issues. Yeah, and then he sets up the environment here, um, creates um, kind of Markdown files, and he creates a first version of this triage workflow. Yeah? So he creates here a triage issues Markdown file, which then contains the workflow. Yeah? And what it is doing is it looks at incoming GitHub issues, um, and it assigns labels and adds helpful comments. So, for example, if I create an issue, or if a user creates an issue about a bug, he will assign the label bug. And if a user creates an issue about a documentation or a request for improvement or new feature, the agent or the workflow will automatically assign the relevant tags to it and write additional comments. Yeah? And here you see that the agent even created here a first version of this twice issue Markdown file. Yeah? Then so Copilot is generating this. It noticed that also a few things didn't work, so he fixes it, and then he compiles the workflow, checks the security, etc., and then he gives us a summary of what he did, yeah, and then I can merge back this pull request from GitHub. So all I did is I instructed the agent create a workflow, yeah, to triage issues, and he created here this workflow, and it does analyze the issue content, assign the appropriate label as I described it, bug enhancement, documentation questions. It also tries to figure out the priority of this bug, and thanks to reporter summarizes the issues, etc., etc. And you see here it added a workflow solution file, and it was successfully compiled with GitHub Agentic Workflow, and now I can see it, and I merge this back, this pull request, and then I can use it. So under GitHub Workflows, here I have now this issue triage workflow, which I can use. Yeah, I tested. I can then also test it. So what I did is I created some issue here. You can see here I created a small issue here, missing tutorial how to use the Python library. So I wrote a small issue. We should add a tutorial how to use the Python library. It should contain some source code example, how to use it, and corresponding documentation for these two use cases I described. And then you see here the agent kicks in and says thank you for opening these issues, and it um, assigns then the appropriate label. Yeah, so it's an enhancement issue documentation, maybe also a good first issue for somebody who could um, contribute to this thing. So this is done completely automatically. Yeah, and I've also um, used it here for other issues. Yeah. So getting back to our PowerPoint presentation. We can see there's also collection. So here I created a workflow myself, yeah, also via agent. Um, but I mean, there is a library already created with agentic workflows, and this is Peli's agent factory. So over the course of this research project, so when they developed GitHub agentic workflows, they also developed these workflows, yeah, and in their own dog food. And so over the time, they operated over 100 automatic agentic workflows, which you can also consume here in this GitHub Next agentic workflow collection. So there's a lot of things. For example, they also have, I've created my own triage incoming issues, but they have also a workflow for that. So I should not develop it myself. Maybe I should use this one here. Then they have things for maintaining documentation, for improved test coverage, for monitoring security. Yeah, you name it. So even write poetry to boost the team morale. They have some kind of agentic workflow here. Yeah, and some of are read only, and others require API keys or tokens which you have to set up. Yeah? So before you write your own workflow, maybe have a look at this agent factory with the over 100 already existing agentic workflows. Okay, what I want to show you also um, in this presentation is how the project evolved over time. Yeah, so if you look at, for example, the contributors here, you see that most of the software development now is not done in a classical prompting or coding way um, from the developers, uh, but instead all the project members here, Peli, Don, and the others, they command the agents, yeah, and most of the agents then generate, for example, via Copilot, the code, yeah. So the top committer here, meanwhile, as the project is self-hosting, and the way how you develop software is instructing agents, yeah, how to implement features, and so the agent, meanwhile, is the top committer of this project. Yeah, and if you think about this, maybe also the metrics for contributor have to change sometime in the future, because currently we only measure in lines of code, but I think we should also think about maybe reporting bugs or requesting new features or planning new features is also a contributor a metric that should be obeyed in future. Okay, let's see how you can then, for example, implement a new feature in GitHub Agentic Workflows. So I have suggested here. Let's find it out. It's already implemented. So, for example, I had a bug here. Let's open this one. I had a bug where this command GitHub Agentic Workflow status had off by 3 error. So there are some internal workflows which are used, or some imported workflows. And so the effect was, if you did a status command here, it reported back 6 workflows, but in reality there were only 3 public ones. Yeah, if you list them, of course there are some internal ones, so these are 6, but they don't count. Yeah, so I described it here. I noticed a small bug. Yeah, there are 3 workflows, but the message says 6. Yeah, so please this and maybe display. We fetched 3 public and 3 internal workflow instead of fetch 6 workflows. Yeah. Okay. What happens now is that Peli assigns this to Copilot, and Copilot itself fixes the complete bug in a pull request here. So without any human, it was possible to fix this bug. Yeah? Only the agent fixed it with this information and small instructions here during the implementation. Yeah, you see here, Copilot makes a plan here. It lays out how the solution should be. It implements it. Yeah, and there are small fixes here from a human in the loop, but all the other things can be done completely automatically. Yeah. I also had an enhancement here, so I suggested here, let me show a second example. I suggested, instead of GHAW status, I would have a list command, yeah, that lists the existing workflows without checking for the status, and also this was completely automatically implemented via such a combination of different workflow agents. Yeah? And even adds documentation for this. So if you check now the GitHub website for this new command, there are a few examples for it. And if you check this pull request, how Copilot did, yeah, he added also here a documentation a thing here. Yeah? So let's check this here. Yeah, it documents the new list command which I invented, yeah? And you see here in the tutorial for the command line interface, we have now here a new list command documented with some of the things. Yeah, so I think we will our way of working will change from instructing agents in our IDE to instructing making complete specifications, yeah, in the bug tracker, and then the agents automatically implement the feature themselves. Yeah, and note this is implemented in a reproducible way. So I am not hacking into my local agent or local IDE. This is transparent for all the team members. Everyone can see this in the bug tracker how it was implemented, and it's traceable, yeah, completely traceable how it happened. These solo IDEs that we currently still have, it's not traceable at all. Yeah, at some time you don't see the prompt that the user entered, etc. And at some time the user commits the code, yeah, and you don't really know, yeah, who has written the code. Was it the AI or was it the user? And as a um, as a fun fact, Peli has even and the team has even written a quality checking agent which checks the other, and I think it's called in favor of the James Bond theme. It's called Q, something like that. So I had to put here, of course, Miss Moneypenny and H&M and Bond itself. Yeah, but we have a quality checking agent that checks the quality of other agents. Very good thing. So, bit of summary. GitHub Agentic Workflow is outstanding, and it's not only a coding agent. I've listed here a few of this coding agent, you name it, different vendors or hyperscalers have offerings for local IDE things, yeah, Google Gravity, Try, Cloud Code, Ralph Inferno. I don't want to mention these things like Moltbot or Clawbot because they are high security risk in my point of view. But GitHub Agentic Workflow is playing in another league. Yeah, this is not a local coding agent. It's an enterprise ready, safe, ready to use agentic workflow with over 100 workflows, which have been used internally also in GitHub Next in several projects. And there's also an interesting blog and experience report about that. So they're very open about that, and I really like it. So GitHub Agentic Workflow, it's a collection of agentic workflows, yeah, over 100. They are secure by default, so we have network isolation, safe outputs. Reproducibility is key. We have server-side builds. Everything is versioned. Um, it's designed for usage in enterprises and not for solo projects. And as I said, it is also used internally in GitHub and GitHub Next for larger scale projects. Yeah? It comes with best practices, tutorials, examples. You can even contribute yourself. So I invented this list command here, and I think the key point you should take away is this is really mind shift from single session IDE to agentic engineering at scale. It's not yet anymore a research project. Meanwhile, it's transitioned to technical preview and moved to the official GitHub from GitHub Next to the GitHub URL. And I think a research topic which we have to cover in future is how do we count metrics for contributors in agentic times. I think this has to change it. Only counting committed source code, I think, will not do it anymore, because you saw top committer is meanwhile Copilot itself. So here are a few URLs you can check. This is the main site. The agentic workflows is still at GitHub Next. There are also blogs, and you can check these projects. I have listed also the URLs for these solo IDEs, and yeah, there's also these links to the AI generative. And the images I have created with Gemini for this. So thank you for your time. I hope you had some interesting, or you got some interesting points, and I wish you a lot of fun with GitHub Agentic Workflows, and see you next time. Bye.